Good morning. My name is Kelsey Wiest, and I'm a member of the Hawks Learning team. Today is the second and final day of the Innovative Educator Summit. Welcome to those of you who are joining us for the first time, and for those of you who are returning from yesterday, I hope you found the sessions enjoyable and informative. We're really glad to have you back. I'd like to take a moment again to express our sincerest appreciation to all of the speakers who presented yesterday and those presenting today. Thank you so much for sharing your expertise and experience. We truly appreciate your participation in this event. As a reminder, all sessions will be recorded, and we will send out information on how to access the recordings after the conference. We're thrilled to have Dr. Heather Collins, a cognitive neuroscientist, leading today's keynote session on leveraging the power of brain science. Heather's expertise is in applying brain science to solve organizational challenges, and her track record of impactful TEDx talks promises to provide actionable insights for personal and professional growth. Let's welcome Heather as she delves into the transformative potential of brain science. And with that, I'll hand things over to you, Heather. You muted yourself.
Good morning, Kelsey. Thank you so much for that introduction. And good morning to everybody out there. It is March 1st, and that means we have survived Leap Day yesterday, and we have leaped into March. Very excited about the upcoming spring and the end of winter. As I get at my PowerPoint today, I want you to think about a question, and that is, are you stressed? Have you recently been burned out at work? And the answer to that question is probably yes. And what does that have to do with the brain? Well, it actually has a lot to do with the brain. Today, we're going to be talking about 10 top thinking habits for lifelong and successful brain function, and basically tips that you can use to help your brain do its best every day, to help you reach your goals, to help you experience greater pleasant experiences throughout the day. We're going to be tapping into some tips from brain science to help you charge your cognitive, social, and emotional brain. And as you can imagine, the first place we have to start is by managing stress and avoiding burnout. If you answered that you are stressed out or that you've recently experienced burnout, you're certainly not alone. According to an American Psychological Association Work in America survey, 77% of professionals reported experiencing work-related stress in the last month, and that includes most of us. What happens when we're under stress is that essentially our brain is on fire. That is, we have neurons firing that aren't supposed to be firing. We have brain networks being used that aren't supposed to be used. We have networks that need to be used to accomplish important tasks, to grade papers, to develop lesson plans, to speak with our students. And we can't do that effectively if our brain is on fire, our neurons are being harmed, and we're under pressure because of burnout and stress. When your brain is under fire, it's almost like a moody teenager is yelling at you for no reason. I'm sure many of you have experienced that sort of thing. You think the teen is fine, you ask them a question, and all of a sudden, they change on a dime and end up yelling at you or getting very angry for seemingly no reason. Well, that doesn't just happen to moody teens, that happens to us when we're stressed and our brain is in firefighter mode. Firefighter mode is bad for your brain. It leads to what's called emotional reactivity. And emotional reactivity is a dysregulation of your brain's limbic system, including this little structure in red you see near the center of your brain called the amygdala. The amygdala is responsible for regulating emotion, controlling fear, and communicating information to other parts of your brain, such as your frontal lobe, which is what you really use for thinking, decision making, and other complex cognitive processing. That is, when your brain is under firefighter mode, when you're experiencing an extreme level of burnout and stress, your hot, emotional limbic system in your brain shuts down your brain's cognitive system. That is, that emotional reactivity prevents you from actually thinking, problem solving, and working towards achieving your goals. So it's really important that we do what we can to shut this down. How do we shut this down? Well, we can use metacognitive awareness. The first step is thinking about our thinking, and that's exactly what metacognitive awareness is. Stop. What are you thinking about right now? Maybe you're thinking about what you're going to make for dinner. Maybe you're thinking about what your plans are for this weekend. Hopefully, you're thinking about what we're talking about right now. Maybe you're really thinking about how stressed out you are. Well, this is metacognitive awareness. It's simply thinking about your own thinking. And this is an important step you can take, not just for reducing burnout and stress, but also just moving forward and creating good thinking habits in the future in all areas of thinking and problem solving and reasoning. When you stop and you ask, what am I thinking about right now? If you feel and sense that you're stressed and you're frustrated and you're not thinking because you're under burnout, you can take a few steps to immediately mitigate that. And as I said, the problem is a dysregulation in your emotional system. So let's regulate it. Let's take that sympathetic nervous system that's elevated, that has that fight or flight response, and balance it out with that parasympathetic nervous system that's more responsible for resting and digesting. And you can do that a few easy ways. You can stop and take a few deep breaths. You can talk with a friend or family member. You can go for a walk. You can listen to some calming music, engage in some mindfulness or meditation, even just for 5 minutes. You can, if you're working from home, walk over to your favorite fur baby, cat or dog, and give them a scritch for a few minutes, and they'll love you back too. All of these things help to bring back regulation between the parasympathetic and sympathetic nervous systems. You'll find that your palms stop being so clammy and sweaty. Your heart rate decreases and you feel calmer and you'll be more able to focus on the task at hand. So when you're thinking about your own thinking, regulating your emotional system is one benefit, but also using metacognitive awareness has other benefits. This is a brain image. To the left, we have the nose of the brain, that is the front of the brain. And to the right, we have the back of the brain. And using metacognitive awareness allows us to monitor how we're thinking and what we're thinking. So that means it helps you make progress to your goals. What am I thinking about right now? Where should I be in this project? Do I need to move forward in this project at a quicker rate? Maybe I plan to write out 5 lectures today, but that didn't work and I only had time to edit 1 and fully write 2. So it allows you to evaluate where you are and plan ahead. It facilitates adaptive cognitive control. And these brain regions here that are highlighted, specifically connections between the ventral and dorsal medial prefrontal cortex that you see up in the front and precuneus in the back, these areas are significantly stronger in people with high metacognitive ability skills. And metacognitive ability isn't just a yes or no ability, it really is a skill. So this is something you can practice and become better at, and it'll become one of many good thinking habits. One specific example is, what's the capital of Chile? Find your answer and then rate your confidence. How confident are you that you're correct? High, medium, or low? The interesting thing is that assessing your own confidence, that is just evaluating how confident you are of what you just said, is a great example of metacognitive awareness This is a very simple way to practice developing your metacognitive awareness. And this works great with students too. So you can stop in the middle of your lecture or insert a slide in the middle if you're teaching in a remote fashion and simply ask your students a quiz question and how confident they are. And that's a great way to promote metacognitive awareness with your students too. And the more they are aware of their own learning, the better questions you're going to get in class. And if inevitably, the higher scores they're going to have on exams because they're going to be more aware of what they know and what they do not know. And by the way, the answer is Santiago. That's the capital of Chile. Number 3, don't multitask. People really don't like hearing this, but it's so important. Your brain is an excellent complex system, and it's really good at doing one thing at a time. When you multitask, you end up overloading your brain. This is one of my favorite research studies. It was done by Ira Hyman et al. In 2009, and it's a study on multitasking on campus. A clown on a unicycle was riding through the quad of campus, and then students in the area were surveyed, and they were simply asked, "Did you see the clown on the unicycle? Yes or no?" Now, among the students who said yes, they did see this very, very bizarre scenario of a clown unicycling on campus. Those without a cell phone in their hands, 85% saw the unicycling clown on campus. And with a cell phone, only 25%. So this is just one example, a fun one, albeit at that, at the perils of multitasking. By the way, you can imagine if they don't see a unicycling clown cycle right in front of their face in the quad, when they have a cell phone in their hand, how are they going to be able to pay attention to what you're saying in class if they have a cell phone? Probably not very well. They're going to be multitasking. There's the well-known saying that multitasking is screwing up several things at once, and decades of research show that this is true. There's always a cost to multitasking. It is screwing up several things at once. So you're better off picking one thing and doing it successfully. When we look at the myriad fMRI studies of the brain on multitasking, we see that anytime multitasking is involved, there's a decrease in both performance, that is, people don't answer correctly, and there's a decrease in effectiveness of response time, that is, people are slower. So you're slower and you perform more poorly if you're multitasking. You certainly don't have 8 arms like Mr. Octopus here, and you definitely don't have 8 brains. So make life easier for yourself and your brain and just don't multitask. Another really nice feature of metacognitive awareness is that it can actually help you set boundaries. And setting boundaries is incredibly important for both multitasking and reducing interruptions while you're working. So when you ask yourself, what am I doing right now? What am I thinking right now? How's my progress on this particular task? You might find that you're not exactly where you want to be, and that's okay. Evaluating that with metacognitive awareness allows you to take the time to actually set a boundary. So maybe I set a timer for 10 minutes and I set my next goal to be done in that 10 minutes. I want to write 5 slides in that 10 minutes. And after that time is up, I'll reassess then. And during that 10 minutes, I am going to remove all distractions. I'm going to stick my phone in my desk drawer. I'm going to set my laptop on do not disturb. And I'm going to close my office door for 10 minutes so that I have uninterrupted access to my task at hand. And doing this, setting these kinds of boundaries actually is a really great way to focus your prefrontal cortex. So unlike multitasking, when your brain is literally scattered on tasks, focusing your prefrontal cortex by setting boundaries is a way to really take advantage of everything your brain has to offer. Number 4, make time for transitions. And just like multitasking is bad for your brain, well, not taking time for transitions is also part of your brain. As we said earlier, being able to take into account everything you have to do all at once is going to overload your brain. And so, therefore, you want to set priorities and boundaries. You want to do task A, then task B, then task C. And making time for transitions is especially important. Research has shown that interruptions and rough transitions, that is not accounting for transition times, can actually cost you 15 minutes of productivity per instance, up to 15 minutes per instance. When somebody barges into your door, or somebody wants something from you, or you have to pick up the phone and address somebody's needs. And that's really bad for your brain. Your brain has a hard time getting back on task, and it really causes stress and that increased production of cortisol in your brain, that stress hormone. And an increase in that cortisol level, that stress hormone, is going to prevent you from functioning at your optimum. Another benefit of making time for transitions is not only reducing those interruptions, but allowing your default mode network time to rest and reset itself and refresh. So, your default mode network is everything you see here in those warm yellow and red colors in your brain. On the bottom, we have the two outsides of your brain, left and right. And on the top, we have the two insides of your brain, left and right. So you can see that there's a really vast network of brain regions that are connected. And what they do is basically keep your brain humming along at a reasonable level. So your default mode network is essentially your brain network that's just humming along when nothing else is going on. Your brain never turns off. Well, it does once, but it's when you die. So that's no good. Even when you're resting, you're sleeping, you're sitting and watching TV, you're scrolling on your phone, you think that nothing's happening in your brain. Your default mode network is still humming along to make sure all your basic functions are happening and that your brain's cruising along, kind of preparing itself for what's coming next. When you allow a transition time from one thing to the next, you allow time for your default mode network to refresh, repair, and rejuvenate itself. And there's some research that suggests that every 20 minutes or so, it's good to actually take a little bit of time to let your default mode network do this. Take a few minutes to stop, take a breath, and let your default mode network cruise along for a few minutes. 5 or 10 minutes is plenty, two if you have it. And keep that in mind also when you're talking with your students. They also have default mode networks. So if you find that your students are getting squirrely in their seats after about 20 minutes, this is why. They need a moment for their default mode network to refresh. And that doesn't mean you have to take a 10-minute break. Maybe just take a 2-minute break. Maybe take a moment just to ask people, stand up, stretch, turn around, and sit back down again after a minute. And that could be enough to just help their default mode network refresh a little bit and really rejuvenate their brain and get them ready for the next part of class. Number 5, bite-sized chunks are key to memory. If you have a paper and pen right now, this would be a great time to get them out. If you don't and you have a laptop or a phone, you're welcome to use that. We're going to do a memory experiment. You're going to see words flash on the screen one at a time in front of you. They're going to go pretty quickly and it might feel difficult. That's okay. It's supposed to feel difficult. If it was easy, it wouldn't be a memory experiment. So it's okay for it to feel a little bit challenging. I want you to try to remember all of the words you see. Don't write anything down. In class, that might be called cheating. Here we call that being overly ambitious. So you're just going to look at the screen and remember the words in any order you like. Are you ready? Let's begin. Now, write down all of the words you remember in any order. And if you're sitting with a friend or colleague today, no collaborating on this part. Okay, try to wrap it up and write down any last words you might be thinking of. And let's see how you did. Which words do you remember? We're going to be on the honor system today and grade ourselves. The words were clock, skeleton, door, girl, watch, jelly, heart, hammer, park, elevator, ocean, bean, cake, phone, moon, square, fish, fire, boot, and library. So how many did you remember out of 20? I have an idea that there are a few you might have remembered. Let's take a look at the first three, the last three, and the three words directly in the middle. If I were to gather all of your data and create a graph and look at the percentage of people who recalled each word from the first word clock to the last word library, that graph would look something like this. And this is what's known as the serial position effect. And that is the group of first words and group of last words are better remembered than the words in the middle. So I have a feeling a lot of you remembered clock, skeleton, and door. This is what's known as the primacy effect. That is, words at the very beginning are better remembered because you have more time to rehearse them. I'm sure each and every one of you tried to use some strategy to remember these words. And you might have begun with repetition: clock, skeleton, door, clock, skeleton, door, clock, skeleton, door. And you were able then to take clock, skeleton, and door and successfully encode them into your long term memory to remember later on. Now, at the end of the word list, we have those last three words: fire, boot, and library. You might not have been able to repeat them the same way you rehearsed the first three because your brain was full of 17 other words by the time you got those. But those were still in your working memory. Your working memory holds information that you're currently thinking about for a period of about 20 to 30 seconds. So you could take those three words from working memory and essentially do a brain dump and write them down. And for a lot of people, fire, boot, and library might actually be the first three words you write down. They're very, very well remembered. This is what's known as the recency effect. So primacy effect, the first bits of information you hear are well remembered. Recency effect, the last bits of information you hear are well remembered. By the way, this also holds when it comes to presenting information to our students. So you might find that if you have a long lecture or a particularly complex topic you're discussing, at the end of class, you ask them what they remember, and they're going to more likely than not remember the first few things you said and the last few things you said. And the stuff in the middle, we all tend to not remember very well. So bite-sized information is clearly key. And this is your hippocampus in your brain. And your hippocampus is responsible for taking in new information and forming long-term memories. Bite-sized information is key. And we have primacy and recency effects, but what can we do about the stuff in the middle that people don't tend to remember? How can we boost our memories to try to be better at remembering that? Well, we have number 6, use meaning and imagination to boost your memory. Be more likely to remember the stuff in the middle that people tend to forget. Think about an apple for a moment. You're probably thinking about a piece of fruit with red skin that can fit in your hand and has a stem. Maybe it doesn't go much beyond that. But let's take a moment and think about another apple. This apple is a Granny Smith apple. It's a really large, weighty one, and I can feel the heft of it in my hand. And as I hold it and look at it, I notice the lime green skin has a waxy coating to it. And this one has a particularly long stem that's kind of curling around to the side. I can smell that scent. And as I take a bite, I can hear the crunch in my mouth and my glands juice up inside my throat. And I have a little bit of juice running down my lip, and it's tart and a little bit sweet. And as I crunch with every chew, a smile grows on my face because this is one of the most delicious apples I've had in a long time. That is the difference between using imagination and not. Your brain functions based on meaning and imagination. So this is a representation of what's called your brain's semantic memory network. You can kind of think of it as your brain's Wikipedia. It contains all of the information you know about the world, and as well as how related that information is for you. So in this particular semantic memory network, mom is at the center of mine. Good old mom. I just love mom. And when I think about mom, I think about pancakes. Mom used to make me pancakes for breakfast with bacon and eggs. But today, sometimes when I have pancakes, I'll have a mimosa. Why not? I'm an adult. That's my prerogative. And when I think of pancakes with eggs make me think of chickens. That's where eggs come from. And chickens make me think of pigs. And where do pigs and chickens live? In a barn? And sometimes horses also live in a barn. And barns are sometimes red. So barn and red are connected. And red is connected with other colors too: fuchsia, purple, and blue. Red is also connected with certain cars, like maybe a Corvette. And red's connected with mom also because she used to get so angry at me that her cheeks would turn bright red and she would scream at me, "Heather Ray, you get back here right now," as I would hightail it off, trying to avoid whatever trouble I had gotten into. Red also reminds me of cherry, and cherry's related to apple and peach and lemon. So the interesting thing here is that this is going to have some commonalities among all of us. With respect to the concept of bird, probably all of us have duck and robin connected, but it's also going to have some unique features. That is, for me, mom is connected to red, but for you, maybe mom is connected to blue because that was your mom's favorite color, and you always think about her blue eyes and her favorite color being blue, and she used to wear a lot of blue clothes. So we can make certain predictions based on commonalities of how people remember things based on what we know about society and semantic networks. But the interesting thing is, this isn't just a fixed Wikipedia scenario. You can be the Wikipedia editor of your own semantic memory. So the key here is that memory operates based on meaning. Meaning is important to memory. Have you ever thought about how difficult phone numbers are to remember, or at least were to remember back in the day when we needed to do that with dial-up phones? That's because the numbers are largely arbitrary. They don't necessarily mean anything to us. So thank goodness for cell phones. We really don't have to remember phone numbers anymore. How many phone numbers do you know by heart? I know moms. But words and concepts and people do have meaning to us. So when you're thinking about something that you want to remember, you can act on that information and take that new information and map it onto your brain's existing semantic memory network by making connections. And that's exactly what we did with Apple. We just thought about not a plain old apple, but we thought more about this apple. We thought about apple as relates to the color green. It's a piece of fruit. What does it look like? What does it feel like to eat one? What does it taste like? And by engaging all of these somatosensory characteristics, taste, touch, smell, sight, and linking it on to what we already know about apples. They're delicious. It's one of my favorite fruits. Going to apple farms and drinking fresh pressed cider in the fall is one of my favorite activities. You're more likely to remember this information. And this is something that can work for your students too. If they can figure out a way to take the material that you're teaching them and somehow link it onto something they already know, it doesn't even have to make sense. It could be something really wild and crazy and imaginative, just as long as you get it hooked and make those neuronal connections, you're more likely to remember that information. This is what your semantic memory looks like conceptually in your brain. It's a number of nodes connected to one another throughout your brain. And by nodes, we mean a bunch of neurons. So this could be thousands, hundreds of thousands, maybe even millions of neurons connected together to talk to one another. And these neurons are physically connected by white matter fiber tracks that connect them and send electrochemical signals between those neurons so that one neuron can communicate with the other. The mom cluster of neurons can communicate with the red cluster of neurons and send information to it. Now, when we look at what this actually looks like under a microscope, this is what brains connected neurons look like. This happens to be in the hippocampus of a rat. They tend to frown upon us taking slices out of live human brains. So we have rat brains. And you can see these green bundles right here are neurons. And you can see that they're actually connected to one another. The closest we can get in humans is not an actual slide of neurons like this, but using MRI. That's magnetic resonance imaging. I'm sure a lot of you have had an MRI before, maybe of your brain, maybe of your shoulder, knee, hip. And this is how we do a lot of research learning about the human brain and how it functions. Now, this is an MRI of the human brain using DKI, diffusion tensor imaging technology. And that is, this looks at the white matter fiber tracks in your brain that connect neurons. In essence, these are your brain's information superhighways. And you can see where these projections go. That is, that one part of your brain in the back actually has neurons and white matter fibers, axons that travel all the way to the front of your brain. And from the left side of your brain all the way over to the right hemisphere of your brain, they are connected everywhere. There are millions, if not billions, of connections among neurons in your brain. So when you take the effort to first decide what's important to remember and then act on it through imagination and through applying meaning to it, you're literally changing how your brain works and changing how your neurons talk to each other for the better. And the more effort you put into that, the more it'll just become a habit, an easy habit. You won't just be thinking apple, you'll be thinking all those awesome details about apple without even realizing it. And the more information you have about one thing that you want to remember, the more routes of retrieval you have. That is, the more retrieval cues you have to go for. And imagination in particular is known for making connections with the hippocampus on the left and that prefrontal cortex in the front. And your prefrontal cortex is involved in applying meaning to things. So you can see how wonderful this is to get different parts of your brain working together to achieve a larger goal. There's also another fun thing about memory. Your brain is selfish. It loves itself. And there's a phenomenon known as the self-reference effect. And that is your brain remembers information about you better than anything else. So if you can somehow take information and link it to yourself or how it's related to you somehow, then your brain attaches extra special meaning to it and deems that information to be extra relevant and something that it's going to want to hang out onto. And on the right, we see the prefrontal cortex, which is involved in this. And on the left, you see an MRI study, and that area in orange shows areas that are activated, really highly activated for information that is specifically about yourself. That is the self-reference effect. So we have the medial prefrontal cortex and the ventral medial prefrontal cortex, and those are involved in applying agency about information. That is saying, yeah, this is related to me. I need to pay attention. This is very important. So that's another little memory hack for boosting your memory. Sleep, another little hack. The quick on this is that there have been numerous studies done, and compared to people who did not get sleep, those who did have a 10% advantage of remembering information in the morning. So you can see that memory doesn't just happen. Memory is a constructive process through which we actively shape and organize information. And that's great news because that means you can have some control over how good you want your memory to be. Number 7 tip for thinking is curiosity. Curiosity is so important. Curiosity is how you fire up your brain and get it revved up for future action and future thinking. This is my now deceased kitty cat Alfie when he was 16. Every time I took a shower, Alfie would sit outside the shower and meow as if I was in pain, and he was very concerned for me. And he wanted to know exactly why I would submit myself to this water torture device on a daily basis. So one day, after I was done showering and the shower had all dried out and I had left the door open, Alfie walked in to check it out and sit down, and then realized, oh, well, this is not necessarily a torture device all the time, just sometimes when water comes down. And he learned that water only comes down when I'm in there, not when he's in there. So it's safe for him to go in there and check it out and see what's going on without getting water torture rained upon him. Curiosity is desire, and it's desire to know something or to resolve an imbalance. When you're experiencing curiosity, it's because there's something on the other side that's rubbing your brain the wrong way. In other words, your brain is experiencing an imbalance and it needs to resolve that, because imbalance could be something that's to be feared, to be avoided, something that could be harmful to you. And your brain wants to resolve that in order to figure out what's going on. Your anterior cingulate cortex is really highly involved in curiosity because it monitors conflict. And so when you're resolving curiosity and resolving conflict, your anterior cingulate cortex is activated and sort of decides where that information is to go next. Is it information that's dangerous to you? Do you have to run from it? Send it to the amygdala. Is it information that's going to require some thinking about? Send it to the frontal lobe. So the key here is just to engage your curiosity whenever possible. And it's as simple as asking questions. That's all you have to do. Ask questions. And it's so important because curiosity and asking questions are how we overcome roadblocks.
Dr. Collins, I apologize for interrupting. I just wanted to give you a quick time check. We have about 5 minutes left in our time block.
Okay, thank you. So whenever possible, it's really important to engage curiosity and ask questions. We are running out of time, so I'm going to skip ahead to a couple of other things. One is sensation-seeking status. That is, when we're thinking about ourselves and other people, ask, is this the kind of person who is really excited about new things, engages in dangerous activities, or just tries new things for the fun of it? Or is this someone who's really more quiet and reserved and calm? And one of the interesting things about this sensation seeking is that people who are high in sensation seeking have a go network that they activate. That is this anterior cingulate cortex that we just talked about. It's involved in go, 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 go. Whereas people who are a little more calm and reserved inhibit this, and they're more active, involved in inhibition. So their inhibition network is more active, their response inhibition network than their go network. That is, their stop network is more active than their go network. So if you're talking with someone, just make sure that language matters. So if you're trying to communicate and foster trust, think that their brain might not work exactly how yours does. So are you going to use words with them about, yeah, this is so exciting and new and different and unusual? Or are you going to use words that might speak to someone who really is a more secure person and involved in more kind of low key, restful activities? And you might say, we have a lot of data on this. It's been shown time and time again. This is really going to be successful because of X, Y, and Z. So think about the kind of language you use when you're talking with someone, and really what kind of person you are as well, because that'll help you better communicate with others based on how their brains work as well as how yours works. Last one is to reward yourself. Whatever change you've made, whatever goal you've set, whatever you've done for the day, reward yourself. Go for a walk, buy that little trinket you've been looking for, take yourself out to dinner, spend some time listening to your favorite music. This VTA, ventral tegmental area in your brain, is your reinforcement center. It has dopamine projections to the prefrontal cortex in the front of your brain and that hippocampus that's responsible for memory. And that dopamine provides motivational salience. That is, by rewarding yourself, you're telling yourself, yes, I just wrote a really difficult lecture and I kicked butt on it. And by rewarding yourself, you're more likely to engage in that difficult activity again. So here are the take-home points. Manage stress, use metacognitive awareness, don't multitask, make time for transitions, remember bite-sized chunks, use meaning and imagination to boost memory, be curious, consider sensation-seeking status, language matters, and reward yourself. If you want to hear any more about this, or there's some of this information you want to share with your students, I have 3 TEDx talks available on my website. And right now, I'd love to talk with you about any questions you might have. And thank you for your attention.
Thank you so much, Dr. Collins. Yes, please, we have just a couple minutes left for questions. If you put them in chat, please, if you wouldn't mind putting them into the Q&A, just so it's easy for me to identify the questions. And we'll run through as many as we can in the next couple minutes. One question that came through is, what are some ways to slow down and help my students set boundaries for themselves, give time for transitions, and cut down on multitasking?
Yeah, I think this is very controversial, but I think the biggest way you can reduce multitasking is by not allowing phones, or telling students, I understand some students need phones for emergency calls for family, friends, or work. Tell them that only emergency calls are allowed and you expect their phones to be off of their desks. Phones are just so tempting and we're addicted to them as society. So it's really difficult for students to stay away from that. To keep them on task and keep them refreshed and promote metacognitive awareness, every so often, ask them a question about what they've just learned and use that confidence assessment. Here's the question: how confident are you? And then have them discuss it. And it could take, 60 seconds, 2 minutes, but it just breaks up what's going on and keeps them back on track. And if they have been distracted or they have been multitasking, it refocuses them to what you want them to be thinking about.
Thank you so much, Dr. Collins. I hate to say this, but unfortunately we are out of time. There was one comment while I'm wrapping things up. If you could go back to the slide that has the take-home points. I think there were a few folks in the audience who wanted to record these. And just on behalf of everyone here, I wanted to thank you for all of your insights that you shared with us. I thoroughly enjoyed the presentation, and it looks like there's a lot of really positive comments as well. So thank you so much. Just
Thank
a
you.
few
And if
housekeeping.
anybody, I just
No,
want to say
please.
real quick, if anybody has any questions, my email address was up there. You're welcome to contact me, and I'm happy to answer questions over email as well.
Yeah, and as I'm wrapping up, if you could then move to the TED Talk slide, there's a few folks who wanted to see that one as well. So just a few housekeeping items. The first concurrent session of the day is going to begin at 11 a.m. Eastern time. You can view the chat. I'm going to paste that in just a moment. Take a takeaway point of not great at multitasking, so I'll be putting that in the chat in just a moment here. For the next session, meeting room links and the session feedback survey. You can also access the conference website for a complete list of concurrent sessions and their descriptions. And while accessing the conference website, don't forget to stop by to the virtual exhibit hall and say hello to the Hawks team. While there, you can view a quick 5-minute demonstration, request your free t-shirt, and be entered to win a $50 hourly giveaway. So I'm going to paste all of those links into the chat. And with that, thank you again, Dr. Collins. We thoroughly enjoyed you.
Thank you so much. Have a wonderful day and enjoy the rest of the conference.
Thank you.